Okay, Bismillah. Assalamualaikum and good morning, everybody. First of all, don't forget to uh, scan your attendance in Spectrum. So this is week 7, but our notes are still in week 6 because I owe you 1 week of lecture. Um, Last week, there's a student asked me to update the notes to a newer version in Spectrum. I haven't got the chance to do it yet. Okay, I'll try to do it in the weekends lah. Okay, well, I'm a little bit occupied at the moment. Okay, so let's start our class today. So this week is going to be about vertical and horizontal alignment and also sight distance. Okay, the sight distance concept that we're going to cover will encompass of stopping sight distance for crest vertical curve, passing sight distance for crest vertical curves. These are the two important things. First is the stopping sight distance. The second one is the passing sight distance, both for crest vertical curves. Okay. And then the last one is the stopping sight distance for sag vertical curve. Okay, there is no passing sight distance for sag vertical curve because it does not apply at that configuration. Okay, so sight distance is the distance that you can see an object lying on the road. It's not like the distance that you can see because it is very long. Okay, it means that the distance from you and the object that you can see uh, that is on the road on a vertical curve. Okay, so on crest and sags, the vertical curvature of facility cause sight restrictions. Okay, so if you have a curve here, there is an object behind this curve. You will not be able to see, okay, because it is out of the line of your sight. Okay, only if you travel further, then you'll be able to see the object. Okay, but for sag vertical curves, there is no hidden object except for at night. Okay, at night, if we assume that your headlights only can see up to this point, and it is purely dark around you, so you cannot see an object above here, okay, above the headlight. So, but that is not much of a consideration lah. Okay, okay. The most important one are the crest vertical curves. Okay, so these diagrams are being given in books. Normally, they use this diagram where the S is less than L and S is more than L. This means that the sight distance is less than the length of the curve. Okay, the length here. And then the next case is the sight distance is more compared to the length of the curve. Okay, we'll get into that in a moment. All right, so this is an example. When you're driving, this is in um, Central Spine Road towards Gua Musang in Pahang. Okay, I took this picture before the highway was open. I was doing some audit works there, so I get a very clear pictures lah of the highway. Okay, so you can see that we are heading. We cannot see the roads that is in front of us. Okay, so when we travel further, okay, you can see starting to see the lamp post, the light post here. Okay, so then you can only see part of the road. You still another small section of the road is still hidden. Okay, so this is what we call as sight distance lah. Okay, if there is an object, normally the height of the object that we consider is 15 centimeters. Okay, uh, if there is an object lying there, and as soon as you can see that object, that is the S value, which is your sight, the distance between you and the object lah. That is your sight distance. Okay, all right. So small part is still hidden. Then here, only can you see the entire pavement of the road. Okay. So sight distance for vertical curves, have several elements lah. First is the S, okay, the distance between you and the object at the first instance that you see it. Okay, so this will depend on the height of the object and the height of your eyes. Okay, we have a standard value for the eye height. H1 here is 1.08 meters. Okay, and the H2 is 0.15, 15 centimeters. Okay, so this is the height of your eyes, and this is the height of the object. Okay, why do we take 15 centimeters? Because an object lower than 15 centimeters can pass through underneath the car. If it is higher than 15 centimeters, we assume that it will not pass under the car. Okay, so we use the height 15 centimeters for the object height. For the H1 is the eye height, the height of your eyes, okay, to the surface, to the top of the object. And then this is usual ones lah, PVC, PVI, and PVT. And L is the length of curve, length of vertical curve. Okay, so this is the assumption that I've mentioned just now. Eye height is 1.08 and object height is 0.15. This is for stopping sight distance. Okay, it means that the distance S here is adequate for this car to stop before it hits this object. Okay, your sight distance here is adequate for your car to stop at the instant that you see this object. Meaning that you see this object, you press the brake, and the car will stop. So that is the distance lah. Okay. The concept here, S is the sight distance, and then you have this SSD, stopping sight distance. Okay. So we want to make sure that SSD can fit into S. Okay. Okay. If you want to take into account passing, okay, you need to take the height of the coming car on the other lane. So now H2 will become 1.08 meters. Okay. So as soon as you see the car coming, the distance here must be adequate for you to pass. Okay. There is a slight calculation there, but I'll show you to you later lah. Okay. So we want to make sure that this distance here, PSD, can fit into this. Okay. If this is longer, no problem lah. Okay. But what we are designing it for is that for PSD is more or less equal lah dengan sight distance ni. Okay. So this is why heavy vehicles, they have lights on top of them and behind them here. So this is to make sure at night you can start to see on top of the heavy vehicle light. You can see the lights. Okay, to help you to see, because the headlights here are still hidden below the curve here. You can see the top part first. Okay. So the minimum length of curve satisfying given a sight distance requirement is given by this formula. So we have two formulas here. The first one assumes that L is more than S. The line of sight, the length of curve here is longer than the sight distance here. The second formula is for the sight distance is longer than the length of curve. Okay. But in most cases, we are going to use this one only, because this is the safe one. Okay, I'll show you the diagram afterwards. Okay, so stopping sight distance is designed to provide adequate sight distance to perceive dangerous situation and to take preventive action. Okay, when you see an object on top, on the surface of the road, more than 50 centimeters, you will perceive. Okay, you start to see the the object, and then you start to take preventive action. So the sum of the distance of the vehicle travels from the driver's first possible sighting. Okay, you start to see the object of the hazard to the instant the brake is touched, plus the distance required to stop after brake activation. So you see it, you take maybe what, half a second, 1 second, and then you press the brake. Okay, and then the vehicle will screech and it stops. So the total distance there is that is the stopping start distance. So you may ask, maybe different vehicle will have different braking distance. So what they are the formulas that they have given has taken into account all those factors lah. Okay, especially the reaction time, where the driver's first possible sighting to the instant the brake is touched. That is highly dependent on your physical capability, and that is reflected by your age lah. The older you get, the slower your reaction time will be. I think the reaction time they have used for this maybe berapa? 2 seconds ke? 2.5 seconds tak ingat. Okay, tak apa, nanti kita tengok lah. Okay, so that is very long time lah. The reaction time uh, for a road user. For a younger person, that is not a problem. Okay, even comparing from a person, comparing between a person in the 20s and somebody in the 40s, the reaction time is already different. I've experienced this, okay, for the first time. When there is once in the faculty, they have a machine that it's like a game. Okay, you can start the game, and when you see something pops up, you touch that image. Okay, you have several boxes, and the image is like the uh, knock the mole game, something like that. Okay, so I thought, okay, I'm just maybe early 40s, late 30s at that time. Uh, I think I shouldn't take too much time lah compared to younger person. Okay, okay, but that game has proven me wrong. Okay, somebody in their 20s easily beats me. uh, in general, we can see the difference. Okay, the age will govern the reaction time. Maybe not much, but it has apa tu? It will influence the reaction time. Okay, so the older you get, the slower you get. The slower you are going to be. Okay, passing sight distance is the minimum sight distance for a vehicle passing on two lane, meaning that you try to take the another vehicle in front of you, and then you see a vehicle coming on the other lane, but you still have enough time and space to complete your overtaking maneuver safely. Okay, okay, we'll go into that afterwards. Okay, so this is the formula for stopping sight distance, that is considering the F, which is the friction, and the G and the TR. TR here is the perception reaction time. Here, okay, 2.5 seconds. Okay, so okay, this is assuming gravity is 0. Okay, because anything with more than 30%, the equation becomes quite difficult. So normally we assume it as 0. Okay, so this is SD. A is the deceleration rate. V1 initial vehicle speed, gravitational constant, perception reaction time, and the gradient. And F is the friction factor. Friction factor will also depends on type of car and type of tires that you are using. Okay, but the value that they have in the table is considering uh, lower than average lah. I suppose it is a lower than average tire. Okay, so that if you are using a better tire, then the SSD is going to be better lah, shorter for those vehicles. If you watch on YouTube the comparison of stopping sight distance between tires, they have videos. Okay, the difference is quite significant. Okay, between expensive tires, middle range tires, okay, it's quite significant. Maybe 1 or 2 meters. Okay, it can uh, sum up to that much. Okay, 1 second, please. Okay, so this is the table. Table 3.1 is the stopping sight distance, minimum and desirable for wet pavements. You see here, the whether the pavement is dry or wet will also plays a role. But this table has apa tu, make it simpler for us lah. So the design speed, and then the assumed speed for the condition, and here is the stopping sight distance. Okay, so for example, design speed 80, the assumed speed between 70 to 80, and this is the minimum stopping sight distance, and this is desirable stopping sight distance. Okay, so if G is not zero, should apply, the formula becomes more difficult. I don't have the formula here. Okay, but due to difficulties to estimate whether the vehicles begin to brake, where the vehicles begin to brake, many agencies ignore the effect of the gradient, and they assume anything, any gradient that is less than 3% is equal to zero. Okay, anything that is less than 3% becomes G equals to zero. Okay, so this is the same explanation over here. All right. So now, assuming L is longer than SSD instead of SSD is longer than L. If SSD is longer than L, the relationship between A and LM, A is the rate of change of the gradient, okay, and the length of curve is not linear. So K values cannot be used in this formula. This formula does not apply when stopping sight distance is longer than the L. At low values of A, it is possible to get negative minimum curves. So we normally do not use formulas where SSD is more than L. Instead, we will be using L is more than SSD, because in many cases L is indeed greater than SSD, and when it is not SSD more than L, the use of L more than SSD formula gives longer curve length, and thus the error is conservative and it is on the safe side. So what it means by L more than SSD and SSD more than L is this. Okay, I think most book does not use show in this kind of diagram. They show you the car like the previous one here, but the diagram is not does not really show. They just show that L is more than S, S is less than L. The reality is this: when L is more than S, the curve is very flat, so that the L here is longer than your sight distance. When S is more than L, meaning that it's very steep, it's very sharp curve. Okay, so now the S is more than L. Okay, so this is what it means. So from this diagram, you can see that we will prefer to have L more than S, not this one. Okay. All right, so when we simplify the previous equation, we will get this for L more than S. Okay, A SSD square. Yeah. So this one is for stopping sight distance, and this one is the L for passing sight distance. And the value of k you can rearrange so that it's become k equals SSD square over 404. Okay, it starts from this diagram. Because L is equal to Ka, you can arrange this into this formula. Okay, be careful if you are referring to different textbook. This is for metric uh, units. Okay, American books, they will have different formula. It looks almost very similar, but the formula is different values here. It has different values. So you need to make sure that you are using metric. Okay. This is the design controls for cross vertical curve. So this is the value of k. Okay, they have calculated design speed and the value of minimum and desirable value of k. Okay. Example 1. So a highway is being designed to H2 guidelines with 120 kilometers per hour design speed. One section, an equal tangent vertical curve must be designed to connect the grades of 1% and negative 2%. Determine the L of the curve required, assuming provisions are to be made for minimum SSD and desirable SSD, meaning that we have got to calculate twice. First, we calculate what is the minimum SSD, the minimum L, okay, using the value of L using minimum SSD and desirable SSD. Okay, so the first concern is to determine the SSD, which SSD to use. Okay, so if we ignore the effect of gradients, the SSD can be read directly from table 3.1 tadi. So in this case, the assumed average running speed is 98 kilometers per hour. Here, because the design speed is 120, okay, minimum running speed is 98, and the minimum k value here is 102. Desirable k value is 202. Okay, 102 and 202. So now, the corresponding SSD 202.9. Ya, mana tadi? Kita tengok table yang betul ke ni? Table 3.1, ini table 3.2. Mana table 3.1? Ya. Ya. Okay, ini. So 120 kilometers per hour, and SSD here is 202.9 minimum, desirable 285.6. Okay. So we use the SSD value 202.9 minimum, and A value you calculate from the radius lah. Okay, you get 3. So the minimum length for using minimum SSD is 305.706 meters. Okay. Since 305 is more than 202.9, okay, this is our this is assumption lah. We do not know whether L is more than SSD or not, isn't it? Okay, we just use this formula. So SSD, you plug into this equation, you calculate, you get this. So SSD is indeed smaller than 305.706. Okay, so the assumption L is more than SSD is correct. Okay, now we'll calculate for desirable SSD. So the assumed speed is design speed 130 kilometers per hour. Okay, from table 3.1 just now, the desirable length is 285.6. Okay, again we assume this. Okay, use the same formula, and of course we're going to get a longer distance lah, longer length. So indeed, 605 is longer than 285.6. Okay, so that is the L value. Note that the provision of this desirable SSD requires a significantly longer curve than providing SSD for the minimum average learning speed. So from 300 to 605. Okay. Okay, continue. Example number 1. Solve example, the first example, using K values in table 3.2. So now instead of using the SSD formula, we use this L equals to KA formula. Okay, for minimum SSD, okay, A we have calculated that it is 3. Minimum SSD K equals to 102 from table 3.2. Here, minimum is 102. Desirable is 202. Okay, so you get the minimum length is 306 meters. So you adjust for, not adjust lah, you try for the desirable values, 202, so you get 606. So when you compare this 306 and 606, it is more or less very close to the previous calculation of 305.7 here and 605.7 over here. 1 minit guys, saya nak ambil sore throat sekejap. Okay. So example 2. If the grades in example 1 intersect at station 10 kilometers, okay, change 10 plus 0, determine the stationing of PVC, PVT, and curve high points for both minimum and desirable curve length. So this calculation is from last week's calculation lah. Okay, last week's formula. Okay, so minimum L is 306. Because the curve is equal-tangent, one half of the curve will occur before the PVI, one half is next, one half after. So you know the length of the curve is 306. So 306 divided by 2, you will get 153. So change in the middle is 10. So 10 kilometers here minus 153 meters. You'll get change 9 plus 847. PVT is on the next half. So you plus another. Instead of minus, so here you plus lah. 153 to the 10 kilometers here. You get 10 plus 153. So high point, low point. This is last week formula. Value of K is 102 and G1 is 1%. That is 102 meters. Or at station 9 plus 847 plus 102. Okay. Station PVC here plus 102 meter. So that is the high point ke low point ni. Okay, turun ni naik. Ni tadi side curve okay. Crash curve. Crash curve, oh sorry. Okay, crash curve. So you get the station is 9 plus 949 meters. Okay. Next is passing side distance and crash vertical curve design. Okay, one thing forgot. Is Amir in class right now? Amir that is doing POFA.
Yes, doctor.
I have ordered your mask, but I haven't received it yet.
Oh, it's okay, doctor. It's okay.
Okay. Please WhatsApp me. As soon
Yes.
as I got it, I will try to pass it to you.
Okay, thank you, doctor.
So that, because I don't have your phone number.
Okay, okay. I will WhatsApp you after the class.
All right. Thank you. Passing sight distance and crest vertical curve design. So passing sight distance is a factor only in crest. Okay, because of course lah, sight vertical curve to overtake is not a problem. Okay, only on crest vertical curve. Not okay, not for sight vertical curve because sight distance is unobstructed, looking up or down the grade. Okay, actually there is one consideration here, but we will not cover that in class lah. I'll mention to it afterwards. Okay, again, so this is the consideration H1 and H2, uh, and the passing of the H2 is 1.08. Okay, to allow enough length for your vehicle to overtake the coming vehicle, the vehicle in front of you. So this is the breakdown of the passing sight distance. You have four types of maneuver here, four type of distance. D1, the initial maneuver distance, which includes driver's perception reaction time and the time it takes to bring the vehicle from its trailing speed to the point of encroachment to the left lane. So this is D1. This is your car. Uh, you starting to think, okay, I want to overtake this car because this book is black and white, cannot differentiate. So this is the car in front of you that you wish to overtake. So when you have established that you want to overtake, you have reached this point, and your car has starting to maneuver outside of your lane. Okay, that is D1. D2 is the distance that the passing vehicle traverses while occupying left lane. This one, this entire length. Okay, this D2 is divided into two parts. Okay, 1/3 of D2 and 2/3 of D2. Okay, here, sekejap Okay, you starting to maneuver out. So that is the end of D1. And then you overtake this vehicle and you reach a certain point where you see a vehicle coming. This is another vehicle coming on the opposing lane. Okay, by the time you reach here, this car has moved here. Okay, this happens 1/3 of D2. Okay, so now this is your car. This is the car that you wish to overtake. This is the car on the opposing lane. Okay, this is the first phase. The second phase here, so this is your car. This is the car that you wish to overtake. So you accelerate your car until you can safely maneuver into the back into your lane. In this time, this car has traveled here. So this is 2/3 of D2. By the time you safely maneuvered here, this vehicle has reached this point. And for this car here is D4 distance. Distance traveled by the opposing car. And D3 is the clearance length between opposing vehicles at the end of the passing maneuver. Okay, so you need to have maybe a few seconds lah after you are safely back into your lane, then you pass this coming vehicle. Okay, so that is the breakdown of the distances. Okay, so K values can be computed using assuming that L is more than SSD. Okay, ni dah aku beritahu tadi lah. H1 remains at 1.08 0.08, H2 also 1.08. So the formula for L is longer than PSD is this. You'll notice that when you use this formula, the length of the curve is very significantly longer. Okay, because you want to allow for overtaking. And the K value is this, assuming L is more than PSD. K value is this. And this table gives you the K value for passing side distance. Okay, so this is the design speed, this is the minimum passing side distance, and this is the K value for crest vertical curve. Of course, it is just for crest lah. Okay. So example 3. An equotangent vertical curve is 480 meters long, connects 2.2% and negative 1.5% gradient. If the design speed of the roadway is 80 kilometers per hour, does this curve have adequate passing side distance? Okay, you're just given this negative positive 2% and negative 1.5%, and the length of curve is 400 meters, 480 meters. Design speed 80. This is more or less the type of exercise that you can the type of calculation that you can do for your project actually. Okay, because you already have these values, you can try to calculate whether your curve is adequate for passing or only stopping side distance. Minimum it should satisfy for stopping side distance lah. You can try calculate and put it into your project calculation. Okay, so equotangent crest vertical curve, okay, ini tadi. Determine the length required. So design speed 80 kilometers per hour, L equals to Ka, and K is 310 from table 3.4 here. So design speed here 80, K is 310. So this gives L equals to 1085 meters. Because the L for your design is only 480 meters, so your vertical curve does not have adequate length for passing. So you must mark your road line painting with double line, meaning that vehicles are not allowed to overtake. So this is what I've mentioned just now. Side distance for side vertical curve. It is not much of an issue unless it is in a very dark area at night, where you need your headlight you can only see whatever that is being lighted by your headlight. Meaning that if this vehicle here is a little bit further, you cannot see. Okay, assuming that it does not have tail light lah. Okay, so this is the basic formula. Okay, where it involves H1 and beta. Beta is the angle of the headlight diverging beam. Okay. So assumption here is the headlight height is 0.6 meter and beta is 1 degree. Okay, side distance for side vertical curve. This is the simplified formulas. Okay, when you assume that beta is 1 degree and headlight height is 0.6, you get this formula. And this is the K formula. Again, they have calculated a table using those values. So you get here, this is the design speed, and here is the K values. So I don't have an example for this. So actually, for side vertical curve, there is one more consideration instead of just light beam. If you have a very steep gradient here and here, and there is a bridge over here, meaning that when this car is on top of a hill here, and this car is on the other side, so because there is a crossing bridge, overhead bridge, or flyover over here, or maybe aqueduct or something like that. So this car won't be able to see this vehicle. Okay, that is the second consideration, but we don't cover it in this class. Okay, horizontal alignment, side distance. Okay, so now this is horizontal. Just now it is vertical. So now side distance for horizontal alignment. So these are the elements of a horizontal curve. The most important part here is the tangent length, L, which is the curve length, and then you have delta here, which is similar with this delta. And then you have middle ordinate, M, and then E lah. Okay, the most important part here is M lah, the value of the middle ordinate. We do not want any obstruction within this M, the length of the M here. Okay, so now the formulas. Okay, you have maybe I think well versed lah with these formulas. Several formulas here. The value of tangent and the value of E, which is the value from this curve to the IP. And then you have the middle ordinate formula and the L of the curve. Okay, so this pi over 180 is just to change it to radian, if I'm not mistaken. Okay, horizontal curve is designed with a 725 meters radius. The curve has a tangent of 140 meters and PI is at station 3 plus 103. Determine the stationing of PT. Okay, ini senang sikit lah kan. Alright. So you use this tangent formula here, the T. You know the value of radius. Now you get the calculate to get the delta. Okay. When you have got the delta, you can use the value of the delta to calculate L. So L equals pi over 880 multiplied with radius and the delta. So you get L equals to 276.609 meters. So given the tangent is 140 meters now, okay, stationing of PC is 3 plus 103 minus 140 meters. Tadi station kat mana? PI. So from here PI minus the length of T. Okay, 140 meters. So you get the chainage over here. So this chainage is 2 plus 963. Okay, L you dah calculate 276. So this 2 plus 963 plus L, which is 276.0609. You get the value here, 3 plus 239.609. Itu sajalah. Okay. So this shows you that this L for horizontal curve is the length of the actual curve, not this chord line. For vertical horizontal alignment here, this line here is what we call as chord line. So the L that you calculate is the actual curve length. So going back to the previous week's concept. Okay, when you are cornering, you have several forces reacting on the car. Okay, that forces will depend on the friction, on the angle here, and the weight of the vehicle. Okay, so this vehicle will have the tendency to be pulled out of this curve. Okay, now it depends on the RV, which is the radius of the horizontal curve. Why is it RV? Okay, we'll look after that. We'll look at that afterwards lah. Okay, it's not just R, it is actually RV. Okay, so it depends on super elevation. Super elevated section of a highway offsets tendency to push the vehicle outward. So it is necessary to establish proper relation with super elevation, side friction, design speed, and curvature. Okay. So now the formula for RV is this, where it is a function of velocity, gravity, friction, and super elevation. Okay. Fs normally it will be given in table 3.5. Okay, this is the value of Fs. This is US customary units. This is metric and design speed, super elevation, and then you have the value of RV here, rounded radius. Okay. If you want to calculate, then you can use this formula for V less than 80 kilometers per hour and V more than 80 kilometers per hour. Okay. Example. A roadway is being designed for a speed of 120 kilometers per hour. At one horizontal curve, it is known that the super elevation is 8%. Okay, so the value of super elevation, we already know lah, 8%. And the coefficient of side friction is 0.09. Determine the minimum radius of curve that will provide safe vehicle operation. Okay, so you look here at the design speed of 120 kilometers per hour, super elevation 8%, and side friction 0.09. So you use this formula RV that you need to convert this 120 kilometers per hour to meter per second. In this formula, you need to convert. Okay, so you put in the values of V here and gravity, side friction, and super elevation. So the radius is 666.457. This is the minimum radius because the radius is larger than 666.457. Uh, because radius larger than that will generate centripetal forces lower than those capable of safely um, being supported. So minimum it must have 666.457 meter of radius. Okay, I still haven't explained to you why this is RV. We'll look at it in the next segment. Okay, stopping side distance and horizontal curve design. Okay, so you cannot see lah. This apa tu behind this curve here is hidden due to an obstruction, which is this apa tu slope on the left side of the road. So as you travel, so this is the uh, speed limit. Okay, speed limit posted speed for this curve. So as you travel further, you're starting to see a little bit more, and suddenly you can see there's a civilization lah. Okay, right after the corner. Okay, so you need adequate distance or clearance. But for many cases, for example, this highway here, there is nothing you can do lah, unless you are willing to cut this entire slope to provide adequate side distance. But it is not much of a problem because this is an expressway. This is actually not an expressway. This is a highway, but the facilities, I think this is R1 road. So it is 4 lane, 2 carriageway. Right. Okay. So this is the stopping side distance design, where you need to consider the L, length of curve, which is from between point PC and PT here, and then the stopping side distance length, and then the value of MS. MS is measured from the middle of the inside lane to the obstruction. Okay, so you have two amount of delta here lah. Okay, delta S, central angle. Okay, and then you have MS yang saya dah beritahu tadi. So this is the most critical element in this diagram. So the formulas, assuming that the length of horizontal curve exceeds SSD, again, okay, L more than SSD. This is the formula for SSD. So you rearrange, you'll get delta S equals to this. And substituting this general equation for middle ordinate to the previous equation, equation 2.42, you get the expression for MS here. So MS, middle ordinate, equals to RV times 1 minus cosine of 90 SSD over pi RV. Okay. Again, you substitute and you solve the equation 2.46 for SSD, you get this formula. So you have lots of formula in your hands. Depend how are you going to use it. Okay. Note that equation 2.44 until 2.47 can also be applied directly to determine site distance requirement for PSD. If these equations are to be used for passing, the distance is given in table 3.4. Would apply, and SSD in the equation will be replaced by PSD. So instead of SSD, this will become PSD. Okay, if the distance is used in the distance that you use, you get from table 3.4. Yeah. Although this is for vertical curve, you can use this value minimum site distance for design. Okay. All right, example. So a horizontal curve on a two-lane highway is designed with 700 meter radius and 3.6 meter lanes. Okay, so now you have two lanes. One lane is 3.6 meters. Okay, one lane is 3.6 meters. So the distance that we need to consider lies in the middle of the inside lane here. Whereas the radius 700 meters here, it is from the center here to the middle of the road, middle of the highway. Okay, that means R is longer than RV. This is RV. RV is the distance from the center point here to the middle of the inside lane. Okay, so this is the value of RV. So now the width of the road is 3.6 meters. To get RV 700 here, you must minus with 3.6 divided by 2. So this road is divided 3.6 divided by 2, you get this distance. Okay, so 700 minus 1.8 meters you get RV. It's shown here. So RV equals 3.6 divided by 2. Okay, R minus 3.6 divided by 2, you get 698.2. So which gives the radius of the middle of the inside lane. Okay, from table 3.1, the desirable SSD is 205. Okay, so design speed is 100. So desirable stopping site distance is 205.0. Okay, so you use the values of RV here to calculate for MS. So we get 7.513 meters of MS. Therefore, 7.513 meter must be cleared as measured from the center of the inside lane, or 5.713 as measured from the inside edge of the inside lane, meaning that 7.513 here is from the middle here to the obstruction, to the first obstruction lah. Or you minus lagi 1.8 here, so the measurement starts from the edge of the inside lane here to the obstruction. So the value is 5.713. So 7.513 minus 1.8. Okay, similarly here, the minimum SSD is 157 meters from the table. If you are using this minimum value, then the value of MS is 4.408 meters. Therefore, minimum of 2.608 must be cleared from the inside edge of the inside lane. Okay. Alright, last example. Makin cepat lah saya buat ni. Kita kena tambah example lagi. Okay, tak apa, tak apa. Okay, two-lane highway, 3.6 meter lane. So this is two-lane single carriageway highway. The super elevation here is 8%. The clearance from the side obstruction from the inside edge is here is 6 meters. And this is apa tu? Stationing for PC and stationing for PT. This curve here, if we go from left to right, this is a curve to the right lah. Okay, this is the horizontal alignment plan view, and the profile view is this. Okay, so it is a vertical curve overlapping combined with vertical alignment. Okay, this is the gradient G1 and G2, and this is the stationing for the vertical curve points PVC and PVT. Okay, a recent daytime accident, driver traveling westbound and striking a stationary object. Okay, a driver driving here to the west. It hit an object and resulted in a fatality, and a lawsuit alleging that 80 kilometers per hour was unsafe for that curve. So evaluate and comment on the roadway design. Okay, what do we need to consider? So the first thing that we need to consider is the horizontal alignment lah. Okay, so two concerns to be checked. So adequacy of the curve radius and the super elevation. Okay, and also the adequacy of the side distance on the eastbound. Ni bukan ni. Ni sepatutnya westbound lah. Saya dah tukar soalan ni. Westbound. Okay, westbound. This should be westbound. Ni yang susahnya. Bekerja dengan apa tu? Diagram from US ni dia terbalik. For the curve radius, note that figure 3.13 that the L, okay, you just minus lah to get the L. Station of PC minus station of PT. Okay, PC 4 plus 160, and here is 4 plus 600. So the length is 440 meters, length of the curve. So calculate the radius using this L. Okay, calculate the radius using this L. You get the value of the radius is 315.126 meters. So this is this R. Okay. Using the posted speed limit of 80 kilometers per hour and super elevation values of 8%, we refer to table. Okay, bukan table lagi. We find that the equation 2.38 can be rearranged. Okay, with the vehicle traveling in the middle of the inside lane, RV minus RV equals R minus half of the lane width. So this the value of R that you get just now minus half of the lane width, you get 313.326. So this equation here, we rearrange so that we can calculate the Fs. We know the super elevation, you know the RV, V square, apa tu, the speed limit, and the gravity here. So you calculate for Fs, side friction. So the side friction is 0.0807. Okay, now we use table 3.5 and look for uh, the Fs at 80 kilometers per hour. So here, 80 kilometers per hour, value of Fs is 0.14. Okay, the value that you calculate is 0.08. So this is less than 0.14. Therefore, the super elevation and the radius are sufficient. Okay. Okay, for side distance, now we need to calculate the clearance. The available ms is 6 plus 1.8 meter distance to the center of the westbound lane, inside lane, or 7.8. Okay, so now you use this SSD formula to calculate the value of SSD lah. Okay, RV, okay, this is the value that we have calculated just now. MS is 7.8, which is 6 plus 1.8 meters. Going back here to this diagram, okay, from the obstruction to the inside edge of the pavement is only 6 meters. So the length that is in our concern is in the middle of the road. So 6 plus 1.8, which is half of the uh, lane width. So you get SSD equals to 140.119 meters. Okay. So from table 3.1, desirable SSD at 80 kilometers per hour is 139.4. Okay. So 80 kilometers per hour, desirable is 139.4. What we calculate just now. So the 140 is adequate lah. More than 139.4. Okay, that's one thing. Turning to the sec vertical curve, the length of curve is stationing lah. Tengok stationing here. Ya kan. 4 plus 140 and 4 plus 290. So the length of the curve, you just minus the two stationing. You get 150 meters. So you just use, you calculate for A first. You calculate for A first. You get A equals to 6 and use this formula. K equals L over A. So the value of K is 25. Check this value of K for the sec vertical curve diagram, sec vertical curve table. So at 80 kilometers per hour, it is still within permissible values. So it should be between 25 to 32. So now the value is at minimum, where it is 25. Okay. So table 3.3 indicates that a necessary K value of 32 is desirable and 25 minimum. Thus, the K value 25 reveals that the curve is adequate for minimum but under design for desirable lah. However, because the accident occurred in daylight and sight distance on sec vertical curve are governed by nighttime conditions, like I've mentioned before, this design did not contribute to the accident. Okay. 1 jam aja dah pula dah. Okay, any questions or anything you want to raise about your project?
Doctor, I have one question.
Yes.
So this regarding today topics is just a simple question. So for example, there's a road, for example, in the Cameron that connect the main road to the tea farm. So the local road is quite small and then it's constructed by cutting some part of the hill, some part of the mountain. So
Yeah.
they cannot consider to put a huge distance of ms, the middle ordinate, and then they put the some kind of mirror. So that's mirror, is it under the requirement from ATJ or is just a common sense by the engineer?
Okay. I think there is no allocation for mirrors. But when we are dealing with reality in Malaysia and also anywhere in the world, the constraints on site, at site, can be very significant. So this calls for apa tu, measures lah, other measures that we can use to aid our design. Okay, we can use apa tu, for example apa tu, rubber strip, apa ni, so that the vehicle will slow down. We have extra signboards, we have apa tu, blinkers or anything to make sure that the vehicle slow down, or you can also put in mirrors. But I'm not sure whether the mirror can be, let's say you say that the mirror is inadequate lah kan, contohnya you kata jalan ni tak adequate, then you can sue JKR. That I'm not sure actually, but there are many cases where we have to actually do things that is out of the normal way of doing things lah. Okay, if the SO, which is the supervising officer of the project, endorses that design, then it can be carried, apa tu, can be done lah. But if anything happens, if you want to fight in court, that SO will have to answer lah. Macam tu.
Thank you, Doctor.
Okay, sama-sama. Welcome. Is that satisfactory answer?
Yeah.
Because in many cases, especially if you want to allocate for apa tu, acceleration lane and deceleration lane at junctions, there is no way you can squeeze in extra lane. In many cases, for example in Johor, they have lots of apa tu, parit, large drain. It's not really monsoon drains, but large drains next to the road. Okay, in many cases, that drain is just a few meters from the edge of the road. So there is no way that you can squeeze in. So you need to use apa tu, some sort of ingenuity lah. That's why we are engineers, isn't it? Okay, to make sure that it is safe. Okay, any other questions? How's your project going on? If you think that what you're having right now is, apa tu, you're so busy, wait until you start working lah. Okay. In most cases, if you're, especially when you are working for private companies, will be much busier than your student life. Okay, you'll find that your student life is rather enjoyable compared to working life. Okay, you have real friends when you're studying. When you're working, office mates are different with apa tu, real mates lah. Okay, if there is no more questions, then I think I'll end the class here. Next week is apa tu, mid-sem break. Okay, I hope you enjoy your break, unless you have thesis to do. But this is the last sacrifice lah that you need to give for your studies. Okay, afterwards, then you're free to go. Okay, I wish you all the best and have an enjoyable mid-semester break. Thank you.
Thank you, Doctor.
Thank you, Doctor.
So much, Doctor.
Thank you, Doctor.
Thank you,
Doctor.
Welcome.
Thank you, Doctor. Take care.
Thank you, Doctor.
Welcome. You too. Take care.
Thank you,
Thank you so much, Doctor.
Welcome.
Thank you, Doctor.
Welcome.